The last method we'll discuss is the addition-elimination method. This is also known as the linear combination method, and a lot of times the text might just call it the addition method. Again, as we talked about in the last two methods, there are three possibilities. One, no, and infinitely many solutions. One solution will have, again, an x and y, and this happens most of the time. Other times, both variables might be eliminated, and in that case, we'll have to see whether it's true or false to determine if there are no or infinitely many solutions. So if it is false, if it's false, there'll be no solution. If true, the resulting equation is true, then we'll have infinitely many solutions, and they'll make it dependent. The steps for the addition-elimination method are as follows. You want to align your variables. You want to put both of our equations into standard form where it's ax plus by is equal to c. Align our variables so that the x's are stacked, the y's are stacked, and then the numbers on the side are stacked. Choose a variable to eliminate. You want to make our variables be the same number but opposite signs in both equations. Add down, solve the equation, and then we'll have to use a little bit of substitution to find the other variable value. Okay, we'll go over this in the next slide. This is actually my preferred method. If I can, I will use addition and elimination because it may be a little bit more thinking than substitution, but there are fewer steps, so fewer opportunities to make mistakes, and it's a lot faster. So for this first example here, we have this system of equations. We're calling the different steps. The first step is to align my variables. So I can already see that this system of equations, each of the equations are in standard form. My x's are stacked, my y's are stacked, and the numbers on the other side are stacked, so they're actually already in order. The next step would be choose a variable to eliminate. We want, again, to choose a variable that either already have the same number but different signs, or ones that would be easy to make the same number different signs. In this one, I can actually look at my variable x. In my first equation, it has a coefficient of 4. In the second, it has a coefficient of -4, which is the same number but the opposite sign. One is +4, one is -4. This is actually going to be my variable that I want to eliminate. You'll see exactly why right now it's called the addition-elimination method, because what I'm going to do, since they're already the same number, different signs, I don't need to manipulate them. I'm just going to add down. And you'll notice that when I add down, one of my variables is going to be eliminated. The whole reason that you want one to be the same number but the opposite sign is that when you add them, they cancel each other out. So in this case, 4 plus -4 is 0. It's canceled out. You don't need to write the 0 on the bottom. I'm just going to cross it out. So now we have 8y plus 2y is going to be 10y. And then I have 20 plus -30 is -10. Now I'm able to easily solve for y. 10y is equal to -10. I'm just going to divide both by 10. So y is equal to -1. From there, I'm going to do what I did in the other method in substitution. I'm going to find my x by substituting this -1 into either of the original equations. The second equation has a bunch of negatives, so I actually might substitute it into my first one. And I did forget to, in the beginning, name my equations 1 and 2. So I'm actually going to sub it into the first equation to eliminate or to avoid negatives. So we have 4x plus 8y is equal to 20. I already know I'm subbing in -1 for y there. So you have 4x plus 8 times -1 is equal to 20. Solving now, I have 4x, 8 times -1 is -8 equals 20 plus 8 plus 8. 4x is equal to 28. From there, I'll divide by 4. So x is actually equal to 7. So now I already know my final answer is going to be 7. -1. And again, because we are new to solving these systems of equations, I will check my answers. So that's the beautiful thing, or the nice thing about this topic, is that you can plug in your answers and you can know if you're correct or wrong. So you can check your own work while you're working. So plugging into the first equation, let me use black here. I have 4x, x is 7, 4 times 7 plus 8 times -1 is equal to 20. So we have 28 minus 8 is equal to 20. That is true. My second equation, -4 times x, 7 plus 2 times -1 is -30. So we have -28 minus 2 is equal to -30. This is also true. So my solution is x is 7, y is -1. But presenting it nicely in a coordinate pair, I have 7, -1. Moving on to the second problem, I noticed that neither of my variables have the same number different sign in the two equations. So I actually want to choose one that would be easy to work with. So actually both of these might be easy to work with, but I can see that, okay, you can choose either of them because I could easily manipulate one of these variables so that it can become the same number, different sign of the one in the other equation. So when I say this, I mean, for example, for this one, if I wanted to eliminate x, okay, so I want to force my x to have the same number, different sign as the other one. So my original one for my first equation, my coefficient of x is 5. Since down here I have a 10, I actually want to force this to become -10. I can do that by multiplying the entire equation by 2, -2, to make it -10. So I'm going to multiply everything, both sides, by -2. From there, I'm going to have -10x minus 2y is equal to -18. And again, all I did was distribute this -2 to each of my terms in my first equation. My second equation, I'm just rewriting. We have 10x minus 7y is equal to -18. From here, I'm just going to do the same thing as the last one. Now I have a 10 and a -10. Same number, different signs for my variable of x. I'm just going to add down. -10 plus 10 is canceled. So you always want one of your variables to cancel. If it doesn't cancel out, then you didn't manipulate it correctly and you'll have to go back. Okay, so you can't do it. The whole point is you want to get rid of one of the variables. -2 plus -7 is going to be -9. Y is equal to -18 plus -18 is -36. Divide by -9. So y is equal to -36 divided by -9, which is +4. The next step would be to substitute for y in either of the original equations. So I'm going to sub 4 y in either 1 or 2. So for this one, I have smaller numbers in number 1, so I'll actually choose number 1. So my first equation is 5x plus y is equal to 9. Substituting in 4 for y, I have 5x plus 4 is equal to 9. Subtracting 4, 5x is equal to 5, so x is equal to 1. I'll check my answers again if I was to sub it in. Okay, I can see that 5 times 1 plus 4 is equal to 9, yes. 10 times 1 minus 7 times 4 is equal to -18. I have 10 minus 28 is -18. This is also true. So my solution is actually 1, 4. Please box your answers. There's going to be a lot of work, so you have to be able to find your answers very quickly. Okay, working on a few more examples. This one we have 5 and 3 and 4 and 9 as our coefficients for our x and y. You'll notice that none of these are multiples of 1 in the other equation. So in order to actually do this, I'll have to multiply both equations in order to get them to the same number. So I'm actually going to look at this x right here. And again, you don't always have to eliminate x. It just happened that most of these we're working with, I'm eliminating x, but you could actually eliminate y if you wanted to. But this one, I'm looking at 5 and 3. These are lower numbers, so I tend to want to work with lower numbers because I don't want to get really high numbers and make it harder for me to add, subtract, multiply, divide, things like that. So we have 5 and 3. So I want to think, okay, what's the least common multiple of 5 and 3? 15, right? So how can I get this to 15 and negative 15? So if I was to manipulate this first one, this first equation, what I want to do is I want to make this 5x become 15. And I can do that by multiplying everything there by positive 3. In the same way, if I want my second equation, my x value to get to negative 15, I want to multiply this by negative 5 because negative 5 times 3 is going to be negative 15. In this next step, I'll distribute my numbers that I'm multiplying by. So 3 times 5x, I'll have 15x. 3 times 4y, we have 12y is equal to negative 90. Now I have negative 15x. 5 times 9 is going to be 45. Plus negative times negative is positive. 45y is equal to 5 times 18. That's going to be 95. Sorry, that's actually going to be 90. Okay, next step is to add down. When I'm adding down, I want to make sure one of my variables is eliminated. 15 plus negative 15, and again, we're adding down. That's why I call it the addition method. 15 plus negative 15, 0. 12 plus 45 is going to become 57y is equal to negative 90 plus 90. That actually is also 0. But I'm going to carry down the 0 because I don't have anything on that side of the equation, and I need something there. So now I have 57y is equal to 0. When you're doing something like this, please make sure you keep working it because some people skip straight to, once they see a 0, they skip straight to no solution or infinitely many solutions. This is not true for this one because I still have a variable there. So I can still solve for y. I'm going to actually divide by 57. So y is going to be equal to 0 divided by 57, and that's going to be 0. Plugging in now, y is 0 to either of the original equations. I'll actually just use the second equation right now just because I haven't really used it. So I have 3x minus 9y is equal to negative 18. Subbing in 0 for y, I have 3x minus 9 times 0 is equal to negative 18. 3x, 9 times 0 is just 0. So 3x is equal to negative 18 dividing by 3. I'm left with x is equal to negative 6. As always, we check our answers. And just a note, if the test does tell you to check your answers, you have to plug it in and show that it's true. So 5x plus 4y is equal to negative 30. 5 times negative 6 plus 4 times 0 is negative 30. Negative 30 equals negative 30. True. Second one, 3 times negative 6 minus 9 times 0 is equal to negative 18. Also true. So my solution here is always x first, right? Negative 6, 0. This next problem, again, neither of my equations are multiples of the other one. For this one, we can multiply either of them, really. I actually am inclined to eliminate x again. So we'll do that. Just know that if you were to eliminate y, it's actually exactly the same thing. You're just using a different variable. So now I have my first equation, my second equation. Oops. Okay. I want to get this 2 and 5. My least common multiple is 10, right? So I want to get it to 10. So I'm going to multiply this 2 by 5. This negative 5, I want it to be negative 10. So I'm actually just going to multiply it by positive 2 because it's already negative. So when I multiply this out, I'm going to be left with 5 times 2 is 10x plus 40y is equal to 30. Then I have negative 10x. 2 times negative 20 is negative 40y is equal to negative 30. Now I'm going to be doing my addition elimination, my addition step. 10 plus negative 10 is 0. Okay. Then I actually have 40 plus negative 40. That also cancels each other out. 30 plus negative 30 is also 0. So for this one, I'm actually left with 0 is equal to 0, right? Because I have nothing on this side left. It all cancels out, so I have 0. I have nothing on this side. It cancels out. So I'm going to look again. Is this true or false, like what we did before? This resulting equation, my variables are gone. So I'm looking at my resulting equation where 0 equals 0. This is obviously true. 0 does equal to 0. So I can know that I have infinitely many solutions. And my system is dependent. Last example here. We've done a lot of algebra work today. Okay, so we have 2x minus 3y is equal to 6. 6x minus 9y is equal to 36. Looking at this, actually my second equation is full of multiples of my first equation. So what I'm going to do right now is, okay, I want to try eliminating y. So I know 9 is a multiple of 3. I do want to make it this negative 3 become positive 9, so it's the opposite sign. So we'll cancel out. So I want to multiply this first equation by negative 3 in order to get this negative 3y to become positive 9y. Multiplying it out, I have negative 6x plus 9y is equal to negative 18. That happens when I distribute this to everything. The next one is staying the same. Okay, so for this one, negative 6x plus 6x, I'm going to be adding down now. That's 0. 9y minus 9y, that also becomes 0. Okay, so I can say that I have nothing left on the left side. However, on my right side, I have negative 18 plus 36, which is positive 18. My variables are eliminated, but I have a resulting equation. This equation is false. 0 does not equal to 18, so there is no solution. Okay, and the system is inconsistent. If I was to graph this, my lines would be parallel. They would not intersect. So that's it for all the methods. In the next and last video for this topic, we're going to look at some applications of linear systems in real life.